Hi guys, how you going? We're going to go through some more projectile motion examples and a couple of things that I want to talk about as well is in terms of access to the Padlet and also the Moodle. Now, in terms of our formula that we're using, so if we start looking at all the formulas that we use in this particular topic, there's not a lot. This one here is the one that we use for the vertical and the horizontal components, all right? So if we start looking at that, if we break into horizontal components, SH equals VHT plus a half AT squared. Now that thing there goes out because the horizontal velocity is in fact zero, isn't it? Alright, so that gives us this formula here for the range, alright, which is SH equals VH0T. Alright, so initial horizontal velocity times by the time. Now when we're looking at our vertical component, it will be V0T plus a half AT squared, and so therefore that formula stays as is. The only other formula we use is really the final velocity formula, V equals V0 plus AT. Right? So, and that helps us find the final velocity at any time. We do have another resource, which is the Moodle, and I'll talk about that in class for you, but that's a password, and I'll put this document up on that so you can see this. So if we're talking about an example of hitting a golf ball towards a tee, and I'm a keen golfer, so I'll be talking about golf and other things that make sense, hopefully to me, and they'll make sense to you. This particular example here, we have the initial angle, launch angle is 35 degrees, and we're launching this golf ball from the tee block, which is basically the same level as the green itself. The speed the ball goes off with is 40 meters per second at an angle of 35 degrees. Now, obviously when we're going, the ball is here, it's going to have a vertical component still going upwards. It's got a horizontal component of velocity. At the top it's got no vertical component, it's only got horizontal, which stays the same as this thing over here. Again, over here the vertical velocity is coming downwards. Alright, so you don't have to worry about that too much. All you need to do is just go through the process that I showed you in the previous video. So the first thing that we will do is calculate the initial vertical and horizontal components of velocity. So if we're using our V0, okay, we substitute our values in there, so 40 is in terms of the actual speed. That's the angle, so therefore that gives us a velocity of 22.94 meters per second. To work out the horizontal component, okay, that's our formula, 40 cosine 30, 32.77 meters per second. Now, keeping in mind that gravity is always going downwards at 9.8, that's our AV that we're using in this formula. So we go down to the next bit, so we now have our initial vertical and horizontal components of velocity. Now the next thing that we always do is we always find our time of flight. Okay, so in this particular case, there is a zero displacement between the vertical and horizontal. So we put our initial vertical velocity in, which is 22.94. We get our t value. That works out to be minus a half of gravity, okay, which is minus 4.9. That's always going to be the case. We rearrange that formula to get t equals 4.68 seconds. Now, because it's going from ground to ground, we know that we could say the time to get to the top of this projectile will be half of that time. It's got to be symmetric. So hopefully that makes sense, and that's showing you the working out to get that. So we're just factorising this thing here, bringing out a common factor of t, rearranging that equation, and that's how we get that particular answer. To work out the range, we simply times our horizontal velocity by our time of flight, and that gives us a distance of 153 meters. So if you did that and hit that on the green, that's a very good shot in golf. You'd be very happy with that. Calculate the maximum height. So therefore, to work out the maximum height, you need to know the time where basically where it's at the top. So you can either say half the time of flight because we know it's symmetrical, or you can use this formula here. Okay, so this formula here, we know that the vertical component of velocity at the top is 0, Alright, so that's that value there. We know initial vertical velocity is that, so therefore we can rearrange that to find our time there. And that matches with what we're expecting to see anyway. Once you've got that time, it's just a matter of putting this into the SV formula. Now the SV formula will tell you the height of the ball or the projectile at any time. So it doesn't have to be just at the top. If you wanted to work out the height of the ball at any time, you could put any time in here using initial vertical velocity and the acceleration formula. So here we're saying this goes 26.85 metres high. Now the last thing you would probably do in most questions is to work out the final velocity. Again, this is a key concept. Key concept is the horizontal velocity does not change. It stays constant because it's got no horizontal acceleration. We have to work out the final vertical velocity. So therefore we're using our V formula. So it's really only two formulas we're using here. So initial velocity is that, our acceleration is that, and the time basically that would actually occur at is that. So this is working in the velocity at 3 seconds. So at 3 second mark it's got a negative velocity of 6.46 metres per second. We could also do that when it hit the ground as well. So once you've got that particular thing, to work out V, you've got to use Pythag. That's my horizontal velocity, that's my vertical velocity. Again, negative sign will go out because when you square a negative number it becomes positive. We're expecting a number to be bigger than that. We also have to work out this angle. The angle over there will be simply the vertical velocity divided by the horizontal velocity. And it's inverse tan of that, so that gives me 11.5. So you need to, if it's velocity they're asking for, you need to give the speed and you need to give the direction, the angle below the horizontal. Alright, so that's an example that we're working through. Obviously, here's another example. There was a guy called Tony Bullymore who was in a yacht race, and he basically got overturned about 500 kilometres south of Perth in the Southern Ocean. And what they had to do was they had to drop a life raft to Tony. So imagine Orion flying above over here at 400 kilometres per hour, 500 metres above the thing. What we need to know is how far away from the boat would you need to let the raft go, or the survival package to go, so it actually gets close to the boat. So in this particular case, we would say the projectile's only got horizontal velocity. Okay, so it's only got horizontal velocity. If it's going at 400 kilometres per hour, if we divide that by 3.6, that's going to give us our speed. Our vertical velocity is in fact 0. Alright, so it's got no... Yeah. In this particular case, the change in height is in fact minus 500 metres, isn't it? It's got no vertical velocity, so that just goes out, and so therefore to work out my time is simply going to be 500 divided by 4.9, and then you take the square of that, because that's t squared, so that's going to take 10.1 seconds to land there. The range is simply going to be SH times by VH. We know the speed we're going at, we know the time it's going to take to hit the ground, so that's telling me that you need to let that life raft go at 1.2 kilometres from the yacht. Right? What's the velocity going to hit the ground with when it hits the water? Well, we know it's going to take 10.1 seconds to hit the ground. We know it's going to go with gravity of 9.8 negative, so it's going to be moving down at that speed there. It's already got horizontal velocity, so to work out the velocity it's going to hit the water, it's got components of horizontal and vertical, so therefore it's going to hit the water with that sort of speed. It's going pretty quick, and then you can work out the angle it's going at by looking at the velocity, the vertical velocity over the horizontal velocity, and so therefore that gives you the angle below the horizontal. So that's sort of information that you'd probably want to know. Now, the thing that's going to vary in these questions is going to be the scenario about where it's landing, going from where it's going to. Now, step 2 is going to be different for different scenarios. So for ground to ground, we know that the vertical displacement is 0. So therefore, the sort of classical way of working it out should be a common factor of t out. Okay, so I haven't got my t, it should be a t at this point here. Okay, so t will be 20 over 4.9. The other common thing that you'll see is this one here, where it goes horizontally from above the ground to below the ground. It doesn't really matter there, but in this case here, the vertical component velocity is 0. So in other words, this is the one we just did before. So it's simply going to be the height divided by 4.9, take the square root. The two negatives will cancel out. Another scenario might be that you go from some height to above the height. All we need to know is the difference in the two heights, and that's our SV here. Okay, so then we get a formula that's going to be 70. We have our initial velocity. We know our half of acceleration. We rearrange this equation into that particular form, and then what we use is our calculator to solve that. So I'll just show you how to do that very quickly. If you go to your calculator, we have an app called PolySim. So if we go to our P, so if we come down to this one here, so Poly Root Finder, so number 1, so I don't expect you to have to factorise things. You do that in maths, but we assume that you can just do that. So the a squared value is going to be minus 4.9. Okay, the initial velocity is going to be, in this particular case, is 20, and then the height is going to be minus 70. Okay, and then all we have to do is press the solve button, and it's saying it's got no real roots, probably because I put the wrong values in. Let's go back to the equation and have a look at that to see if we've got the right equation. It's actually minus, it's plus 6, no, it's 20, isn't it? So 20 takes 70. That should give me an answer of, yeah. Let's try it again. I'll go back to the calculator. So go back to the coefficient one. So minus 4.9, 20, and it says minus 70. So that doesn't seem to want to work. But what I'll do is I'll show you that in class. So it's a matter of just pressing it into some technology and getting your answer for that. Alright, so I'll get you to look at the Padlet to actually know what questions you have to actually do, but you need to work through a whole range of questions so you get the experience of knowing how to solve these problems. But you know, it's just a repeated process, so it's sort of like you can learn a process, but you don't always have to do every step in there. So alright, so good luck with those, and we'll work through some of those in class.